Thank you all so much for coming out to see me. My name is Emily Arnott. This is my first time at Strange Loop, my first time in the city of St. Louis, which seems absolutely beautiful. And I realized yesterday this is actually the furthest south I've ever been, which is a little bit of an achievement. It's honestly bittersweet to be here. I read Douglas Hofstadter's I Am a Strange Loop almost 10 years ago. It had a tremendous impact on me. And to learn that there was this whole conference, this wonderful community that was inspired by those ideas, and then to have the privilege of coming and speaking at it, I was just so moved, I was so touched. And then I learned that it was also the last one, which is a little disheartening, but I'm sure the spirit will keep living on. But that's enough sentimentality for now. I have a little intro for you here on my phone. Good afternoon, everyone. I know, yet another talk on AI. You're probably thinking you've heard it all. From AI saving the world to it accidentally ordering 1,000 rubber ducks instead of just the one. Now, in the realm of software incident management, AI can truly be our knight in shining armor. But like any medieval knight, there's a chance it might just joust its way through the wrong door. And if you're suspecting I got an AI to write this intro, well, let's just say I'm keeping some cards close to my chest. And then it says wink. I don't know if I'm supposed to say wink or wink. A little unclear. But as you may have guessed, an AI did write that intro for me. This is the prompt I gave it, and I'm sure it's no surprise to you now that AI can deliver a pretty meaningful response to this prompt. I asked for a brief one-paragraph intro. I talked about, this is the subject of my talk, but I wanted it to cover the helpfulness, the potential risk. I said, oh, please make it humorous. Put some jokes in there. Please acknowledge that the audience has already heard, even just today, 2 more talks about AI. Who knows how many before that? They've probably even seen this trick before of, a stealthy AI introduction where you go, oh, wow, did you know that was actually just ChatGPT? And then I even specified, don't say that explicitly. I want that to be a surprise. I don't think it was much of a surprise. So let's examine my prompt a little bit. Let's do a little bit of psychoanalysis of what this prompt represents. It's very specific. I gave it a particular topic and then all sorts of requirements on top of that. It seems a little neurotic, obviously. Like, it's a level of demand that I think if you were giving your human employees that much specificity, they would be a little peeved. But it comes from a place of nervousness. Like, this is the biggest stage I've ever spoken on. And I'll be honest, I was a little nervous. I needed some sort of way to ease myself in. From a place of uncertainty, I wasn't really sure what was the audience going to be like specifically. How can I kind of like hedge my bets a little bit? And from a place of novelty, there's an excitement there. You want to bravely go into this new water, and you want AI to kind of lead you there. And this is not too unlike an engineer when they're doing incident response, when something breaks and they have to diagnose it and solve it. It's the same sort of mentality, the same sort of neuroses, the same need for specificity, and the same nervousness. But my request was not something that you would really ever ask of a human. As I said, that would maybe get you labeled as a bit of a micromanager. And that got me thinking, maybe in incident response, we should be asking some things that aren't human, i.e. AI. So I come from a world where we live and breathe incidents. And something that we found is that the definition of an incident, what is and what isn't, is a little bit nebulous. And for this talk, I would really recommend we take a very broad, holistic picture. One that isn't so much about the qualities of the thing itself, but more about the effect it has on you. So what I mean by that is, let's take a look at your typical workday. You have a planned task, then there's going to be a follow-up task to that, a follow-up task to that, and then at the end, you get a nice, well-earned rest. But let's take a look at what happens when an incident interferes. You have your planned task, that goes fine. You're doing your follow-up task, and then something unexpected. This could be anything. This could be all of your services are down. This could be, hey, we've got this bug that we're going to really prioritize because it could lead to another problem. This could be unexpected staff changes pull you into a meeting, and suddenly your whole day is just spent on reorganizing the org charts. No matter what it is, you need to have some sort of process in place so that you're not scrambling, doing everything ad hoc. You need incident response, and at the end of that response process, whatever it involves, you need to make systemic improvements to prevent recurrence. Then after that, it's back to business as usual. Not always. Usually it's back to staring at a screen, trying to remember what was it that I was doing again. And then instead of a well-earned rest, it's more about trying to catch up. So I hope that this very broad, holistic perspective on incidents can really make you appreciate that it's something that all of us deal with in our work, in our personal lives, in our hobbies, whatever projects. Anything that's pulling you away from your plan, you should have a process for. So what makes incident response so challenging? There's a lot of words on this slide, and that's because there's a lot of reasons that incident response is challenging. And I'm not going to say that AI is a magic wand solution that is going to solve all of these automatically, instantly, forever. But we'll see how AI being applied to even just a few key ones of these can create like a positive domino effect where the additional time, energy, and de-stress that you get from these time-saving measures can help you handle all of this other stuff. Probably the biggest one with incident management is time sensitivity. You're acutely aware that every second the incident persists is delaying you from your planned work. It's creating this cascading slowdown effect. You could also be incurring a ton of other costs too. If it's a major outage, then you have no one using your service and no one making you money, frankly. There's a lot of expertise required in resolving an incident. Usually you need a lot of deep knowledge of your code base to figure out what are the root causes here, what bugs could have changed, what has made the situation different from the stable state before. Often when responding to incidents, you'll have a lot of tedious and very ad hoc subtasks. Suddenly you're going to be in a position where you're manually checking through dozens of lines of code that should have been taken care of already. There's also a huge coordination communication problem with incident response. How do you get all of the necessary people into the room or virtual room at once? How do you make sure work isn't done redundantly? How do you make sure you're being effective? And finally, it's all about retaining and using what you learn. You can't just be running into the same pitfalls every single day. You need to, at some point, build a bridge. Okay, so I think the best way to think about how AI fits into this process and maybe makes things easier for you is to look at a crisis scenario, and this is a bad one. 75% of your users simply cannot log into your service. So this is severity 0, the absolute max, all hands on deck. Of course, 75% loss of traffic, loss of revenue, that's no good. The most frustrating part in this scenario is that you can't delineate what is success and what is failure. You don't really understand why it is that 25% of people can still log in. So you think, okay, let's try to examine our code base. Let's look for plausible causes of bugs that could have created this problem. But you've got a huge code base. This is your first roadblock. A user logging in actually ping-pongs through all sorts of different files. You might have to pulse in some profile data and kind of build out how the service looks to that particular user. There could be security checks, which may be subcontracted to a third-party tool, and then that creates a whole big mess as well. There's cookie management. You need to synchronize their experience with what the service expects. And it's a difficult question to say, where does all of this live in your code base? It's probably like in a dozen or more places. And unless you guys are like wizards of documentation, there's probably not just one key word you can search for that pulls it all up. And beyond that, you also want to know, where does this live in the code base that has been changed recently? You're looking for that cause and effect relationship. And I don't know, has anyone had this sort of experience? You've had an issue, you've had a bug, and it's like, where do I even start? It's like 80 places it could be. AI can be your sidekick here. This is already a very common use case for ChatGPT and other large language models. Parsing code with natural language and asking natural language questions about it. So typically these days, models like ChatGPT, you can dump in maybe like one function, one chunk of code, and get pretty reasonable results. But kind of invariably, no matter what technology you are optimistic for, it seems like something that's happening is LLMs being able to scale larger and larger input data. We're hearing now about models that can take in like a whole novel. You can say, read War and Peace for me. Tell me, what are the themes of War and Peace? And this is actually becoming a reasonable thing to expect from AI. So similarly, we can imagine that in the future, and perhaps even in the present, you could dump in significant parts of your code base, if not the whole thing, and expect to have like a meaningful contextual relationship emerge. Then you can just simply ask in natural language, hey, can you highlight everything that has to do with logging in? Can you highlight everything that has to do with logging in that's received some push in that file in the last week? You can start narrowing in just using your own judgment and not requiring this like specific expertise of, oh, but that connects to that, and actually we're still using this old function just for logging in, and all of this tribal knowledge that who knows where it exists. Okay, so let's say you succeed. You find this chunk of code. Let's say it's something that very fundamentally just parses the input from when you log in, just on the level of like taking the text and moving it somewhere to further analyze. And you suspect this because there was a recent global change to your entire service that impacted like every input to that service. That kind of seems like the culprit. You can't just roll back this change though. That's going to break like way too many things. But you know that the error is happening here. It's just kind of within this one chunk of code, but you can't quite weasel out what is making it work sometimes, what isn't making it fail sometimes. So how do you figure out what inputs are breaking it? You could do it manually. You could try to manually come up with some automation for it. But all of these things are pretty stressful, pretty tedious and toilsome in the midst of this crisis, in the midst of 75% of your users being shown the door. So how do you figure this out without losing your mind? And here's another very common existing use case for LLMs, ad hoc script generation. This is probably something that all of my programmer friends do on a weekly basis, if not more. You just need a little thing done. You give it very minimal information. Hey, I need you to test these fields with this types of input. Please output the results in this format. And you're off to the races. Just going to grab a drink of water 1 second as you ruminate on this. I'm sure a lot of you in this room have done that, right? A little GPT script generation. Okay, so let's say this all just works great. You've fixed everything and the users can log in. Are we done now? No, we are, if anything, just getting started. This incident has exposed a major flaw in your system, namely that these deep systemic changes on input can break higher level stuff like logins. So how do you fix this on a systemic level? Well, it's kind of difficult, right? Like we said before, the login process is somewhat distributed. There's probably a lot of different owners for different parts of the code that deal with this. And as I said, it ties into this global inputting system to your service. So probably multiple teams involved. And to get them all up to speed on what needs to be done and what broke, you're going to have to spend hours in meetings. And remember, none of this is your planned work. This whole time, you're hoping to get back to those initial tasks you laid out. So once again, our AI sidekick can leap in with incident, retrospectives, and communication. So this is something that a lot of organizations are already making a priority. Every time something breaks, you draft up a little report of it. You include a timeline, who was talking to, what was tried, what failed, what worked. But AI can really kind of enhance this, build targeted reports without you needing to submit much organization on your end. And what you're aiming for is a model of the incident, something that's been trained to know what happened, that can then be a subject matter expert to other engineers. So that rather than going to you, who's busy with a lot of other work or a well-earned rest, they can just go to this model of the retrospective that can kind of answer questions, bring them up to speed on what they need to know, and help guide them along to the solution, like distributing that solution to other situations. So all this sounds pretty great, right? These are big, big opportunities. You're reducing the stress and toil of engineers, you're minimizing the downtime when something breaks, and because of all of that, you're accelerating your planned work. It's a real compound advantage. But it comes with risks. I'm sure everyone here can think of an example of engineers, a very famous case, they encountered an incident, a problem, while out in deep space and collaborated with an AI to disastrous results. Now, I don't think any large language model you implement is going to attempt murder, but there are some things that it will likely do that you need to compensate for. The first one I want to talk about is black boxing. There's a lot of people that use AI but don't fully understand what is going on the inside. And by a lot of people, I mean basically everyone. The goal of AI is to create something that has kind of power and utility beyond what you yourself are capable of. And similarly, if you get AI to write a chunk of code, let's say this one that helps you parse what logins are working or not working, you go, hey, that's actually a pretty useful tool. I'm probably going to need this for future incidents. We could even maybe incorporate this into the code base somehow. But do you know exactly how it works? Do you know line by line what it's doing? Maybe in simple cases, yes, but the more you rely on the AI, the more you take advantage of its speed, the less you'll be able to have that confidence in every single line of code. And that's okay, because you probably don't have that level of confidence of every single line of human-written code in your code base. The thing is, it creates tech debt. It creates a very specific type of tech debt where there's little black boxes in your code base where you just have to trust things are going to go in and come out the way you're expecting. So the way you deal with this is the way that you deal with any sort of tech debt. You just acknowledge that you are going to accumulate it. Nobody's perfect. Nobody can do 100% code reviews 100% of the time. And you just find ways to schedule time to deal with it, to gain back some confidence in your system, to clean up spaghetti code and black boxes, to document things. And I think, it's just a trade-off. All of these things we talk about are trade-offs. With AI, you get the speed and convenience, but you just need to invest in protocol that can compensate for that. The next one is hallucination. This is by far the most common problem that people experience with large language models. It's something that is basically inherently going to be the case with them based on how they work. If you ask an LLM a question, let's say, what is the library function from AWS that does this thing? And you're in the middle of an incident, you want a response quickly, you think this is the best way to get it, and the AI very confidently tells you in proper formatting, hey, just call this function with these arguments and you'll get what you need. You slot it into your code, you're sitting pretty, you think that was easy, and you immediately get that squiggly red line, this function does not exist. The AI loves confidently making stuff up when it thinks it has to. It's kind of like, when you're in school and you're asked a question and you just don't want to admit that you don't know. Like maybe you think, oh, I was supposed to read that. So you just BS whatever you can and hope you can kind of get through it. That's what the AI is always wanting to do. And here, I think the best system to have in place is just like another layer of sanity check. Like I said, this will never totally be rooted out in AIs. And again, it's like you can't spend all day just kind of babysitting it and policing it. So it's important to just kind of set yourself up that you can't be catastrophically destroyed by incorporating some bad data or making a bad assumption. Desynchronization is a particular type of hallucination. So AI, large language models are kind of trained at a specific time and place. They have a data set that they work on to use to make their model. And that only happens at certain periods. You can't expect to be constantly updating your model, whether that's feeding it your latest code base. You can't expect to do that every time a line of code changes, or pulling terabytes and terabytes from the internet every weekend. So you have to accept that whatever model you use is going to be a little out of touch with the latest and greatest. And again, it's all just about building checks and balances into the procedure. You just have to embrace the idea that AI could be saving you a lot of time, so why not just spend a little bit of extra time and make sure it's giving you something good. So another major issue with AI that I think is going to be taking the forefront more and more as we entrust strategically more and more advanced models of AI, which is misprioritization. So let's go back to our login issue, but think about like a modified version of it. 75% of users still can't log in. Only 25% can get in. And you have no idea why. Nothing has worked so far. Even with your AI buddy, you're not really making much progress. But you do come up with a way to let in an additional 10% of users of your choice. This is maybe a little convoluted. I'm not sure why this would ever happen, but I hope it's illustrative. How do you decide which 10% to let in? Could it be the 10% that spend the most money when they're using your service? Is it the 10% that are currently most dissatisfied and likely to switch to a competitor if they don't have a good experience right now? There's a whole lot of ways you could determine this like selection filter, and you have a ton of user data to parse in order to do so. So obviously you want to get automation involved. And then there's kind of a spectrum to how much trust you give the AI. You can give it very, very explicit instructions on how to sort this user data and make prioritizations. And that's essentially just kind of like a big Excel filter and sort. Or if you're really pressed for time and you're confident in the AI, you can start asking it to think more and more strategically. Leave it up to its judgment of which users are the highest value. And this can actually be quite powerful. Like I think even current AI models have a good enough kind of linguistic understanding to figure out things like, oh, making money is good. Customers leaving is bad. Dissatisfaction correlates with leaving. But the thing is, these are only linguistic relations. They're not facts that the AI knows about the world. And you'll run into these issues of misprioritization where the further you entrust these things to the AI, the farther off course they're going to be able to steer. So once again, it's a trade-off. You save a lot of time and effort by letting it make these judgment calls, but they might not be the right calls. So one thing I really want to emphasize, and I hope that with this crowd, it goes without saying, but the benefits of AI are not an excuse to downsize. You should not be thinking, oh, I have 10x engineers now. They've been 10xified by AI. That means I can fire 9 engineers. I'm sure nobody here has had that thought, but some people have. And I think it's important to really proactively address that. AI should be seen as an investment in your people. It's something that empowers engineers. It's something that makes their lives easier and allows them to get more of the work they planned on done. And in order to really reinforce this message and to continue getting the most out of your people, you need to keep investing in those people, not just in AI. So what does that look like? First, I really want to emphasize process. You need a robust and resilient process. So AI is going to break things in ways we can't currently imagine. You are probably going to get some bizarre errors from using AI-written code or weird resource allocation issues from AI-driven testing, and things are going to break in ways you've never seen before. That's scary. The nice thing, though, is that a novel problem doesn't always need a totally novel solution. There are fundamental things you can do every time something breaks that will always, always work for you. You're always going to need to figure out who are the people best equipped to deal with this process? How do we alert them? Are they on call? Are they burnt out? Are they able to help? How do we get them coordinating with each other? All of these sorts of logistical, higher-end questions are things that you need to solve with process. And what I mean by like robust and resilient, robustness kind of means completeness, like you can account for everything you can think of, which is difficult with AI. So you also need resilience, which is where it's flexible and can adapt and bounce back when hit with things that you couldn't currently imagine, which is maybe a lot of AI. I really think investing in process is what's going to separate, the successful companies and the companies that end up lagging behind when a gigantic explosive new technology like AI emerges. The next thing I want to emphasize is that AI is still in its infancy relative to a lot of technology that we work with. And the pace at which it's evolving and changing and giving you new features and options is mind-boggling. I feel like every day I learn about some thrilling new AI development. And if you're implementing AI in your workspace, especially with something like incident management, you can't afford not to stay on top of these things. Something like hallucination, I said, was just an inherent problem with AI, but it is getting better. In the talk before ours, we saw how AI itself can actually start addressing when it's not confident or when it thinks it's making something up. These are things that are just emerging now that can make your AI tools more reliable, especially in this place where reliability is so crucial of incident management. Another thing I really think we ought to do explicitly is train engineers in AI operations. Now, the big thing about AI is that it's easy, right? You use natural language, you just ask typical questions, and you get amazing results. You can be neurotic, you can be nervous, you can be specific, it doesn't matter. It'll handle things for you. But still, there's a lot of small nuances in how you communicate with the AI that can have big impact in the sort of results you get. Again, in the previous talk, we saw some great examples of this. I've heard all sorts of things about if you give it prompts that start with, think about this step by step and give me a solution, it does a lot better. I even heard if you say, take a deep breath and give me the answer to this, which is just really disturbingly anthropomorphic, but that's just the world we live in now. So teaching engineers about these techniques, letting them have time to experiment, to develop their own practices around this, can make a world of difference, not just in terms of getting better results from the AI, but showing that you're willing to invest in your engineers along with this new technology, and they're not just going to be replaced by prompt engineers or somebody that has been hired in to specialize on this. You got to take steps with your people and with your technology. So thinking about the issue with AI being a little strategically misguided, not having the same priorities as you, the real problem here is that often your engineers don't do much better. And it's not the fault of engineers. Everyone here, everyone that works in tech is a very smart person that understand the fundamentals of what running a good business is. But nobody can really have that broad a perspective while they're also drilling away on Jira tickets. They have a very linear path of what they want to work on. And I think that creates a problem. This creates an issue in many cases, not just with dealing with AI, where engineers don't have the full context of the organization that allows them to make these more strategic decisions. So I think as you bring on AI tools, you need to empower engineers to do this thing that humans are still so uniquely good at, which is prioritize based on the big picture, prioritize based on common sense human thinking, making money is good, losing customers is bad, that AI we can only just hope and assume understand. I think this is really going to be the turning point for a lot of people's careers. Nobody wants to be in a position where they're being replaced by AI, and so everyone should be given opportunities to enhance themselves and to take on that more strategic role. Along those lines, you really need to celebrate the work people are doing around incidents. I would say right now, the overall sentiment towards AI is mixed at best. We have a lot of people out there that see AI as a threat, or they see it as trying to delegitimize work that they have done. They see it minimalizing and marginalizing the contributions they make. And these are problems that incident workers face already. Incident work falls into a category of what has been called very famously glue work. It's stuff that kind of keeps everything together, but if it's done well, you don't even notice it among those seams. And people that do glue work often feel burnt out and unappreciated and unrecognized. It's often too thankless, and it leaves people looking for other opportunities, it leaves you with churn, and not a very stable product. So I think as you incorporate AI and as these engineers deal with the conflicting feelings of, oh, this is such a great opportunity, this makes things so easy, but oh my God, is it so easy now that they can just fire me and I don't even need to be involved? A way to reassure people is with this celebration, recognize achievements, recognize what the human still does to contribute. Lastly, and if you look up the company I work for, you'll understand why this is so important to me and why I saved it for last. I work for a company called Blameless. Building a blameless culture is so important to incident response in general, and I think will only become more important as these AI technologies get involved. So what I mean by blamelessness is when something goes wrong, you don't look for like an individual who is at fault. Sure, maybe someone did make a mistake. Maybe they pushed some code that they shouldn't have, and then everything broke. But if you just stop at like punishing that person, saying never do that again, you're fired, whatever, how will that lead to any sort of improvement? That's like a very shallow approach to dealing with the problem. Instead, you need to wonder what is happening on the systemic level that let this happen? What sort of checks and balances can we incorporate to prevent this sort of thing from recurring? And that's what Blameless is all about. It's about digging deeper into these systemic causes. So what I'd like people to do when they start having these AI agents as sidekicks is to not just blame the AI either. Sure, maybe it hallucinated some weird library function and everything didn't work because of that. Sure, maybe it generated the most convoluted input checker of all time and now nobody knows how to use it and that creates another problem. That's like its mistake, but what can you do on the systemic level to prevent that mistake from happening again? So in summary, I think I might be like way ahead of time. I don't know what the time check is, but we can do a thorough summary here of the, as promised in the title, risks and opportunities. The opportunities are wonderful. Less stress, more time for planned work, happier users experiencing less downtime. The risks, of course, are tech debt, weird new bugs, and engineers that may feel a little bit alienated by this new technology. So how do you mitigate? Invest in process, keep learning the best practices and advancing along with this exciting new technology. Train your engineers to deal with AI specifically. Empower that sense of a greater perspective, that strategic thinking. Celebrate the work they do, show that people are appreciated, and have a blameless culture that extends to AI that helps you address things systemically. So I thought it would be appropriate to end things with a farewell from our new sidekick. Once again, I gave it a almost impossibly neurotic task of another brief one-paragraph outro touching on helping resolve incidents faster with less toil, automate scripts, code-based parsing, also enabling follow-up improvements with better reporting and communication. Please touch on how investing in the humans is important. Process resilience is important. It mitigates risk. And also make it funny. Please don't forget to make it funny. You got to make it memorable. Make sure the audience feels they've seen a glimpse of an exciting new future era of incident management. This is a tall order to be sure. Let's see how it did. All right, folks, to wrap up our journey today, think of AI and incident management like a hyperactive but brilliant intern. This is a pretty good joke. I don't know. It's relatable. It'll race through scripts and devour code bases like a college student on an energy drink binge. Also, maybe all too relatable. Making incident resolution seem like a breeze. It's also that intern that sends detailed, meticulous reports and slides into your DMs with invaluable insights. The use of slides into your DMs is like crazy to me. Like, what does it think that means? But remember, no matter how shiny and impressive it gets, it's still a tad bit clumsy. So invest in good old human resilience and processes as a safety net. After all, we're ushering in a thrilling era of incident management, one where our bots might just bring us our morning coffee while they're at it. I feel like I said, oh, make it inspiring. Are you guys inspired by a robot bringing you coffee? It's all right. Cheers to that, and may your future incidents be both few and swiftly resolved. Thank you, thank you, thank you. I'll advertise where you can get in contact with me. I love talking about this stuff. I love hearing about how other people are using AI. So please reach out to me on Twitter. My DMs are always open. I know Twitter is like the worst site on the internet right now, but I've been too lazy to go anywhere else. Also, if you want to check out some of my writing on this and other topics, blameless.com/author/Emily Arnott. And then if you want to just hear me talk about like totally unrelated stuff, mostly like anime, some movie reviews, I have a YouTube channel too. I thought I would just plug that quick. I think I'm getting played off. So I don't know if there's time for Q&A. I guess not. Feel free to come and speak to me if you have any questions. I'll be around. I'm here all week, folks. All right. Bye-bye.